The US Air Force had modified 747s for a variety of purposes. One of those was an airborne missile defense aircraft known as the YAL-1. Originally a 747-400 fighter, the US Air Force fitted this plane with a megawatt class chemical oxygen iodine laser, or more commonly known as COIL. The purpose of this airborne laser testbed aircraft was to use the aforementioned COIL to destroy inbound ballistic missiles. The Airborne Laser Laboratory was a less powerful prototype installed in a Boeing NKC-135A. It shot down several missiles in tests conducted in 1980s. The Airborne Laser Program was initiated by the US Air Force in 1996 with a contract to Boeing's ABL team. In 2001, the program was transferred to the MDA and converted to an acquisition program. The development of the system was being accomplished by a team of contractors. Boeing Defense Space Security provides the aircraft, the management team, and the system's integration processes. Northrop Grumman was supplying the COIL, and Lockheed Martin was supplying the nose turret and the fire control system. In 2001, a retired Air India 747-200 was acquired by the US Air Force and trucked without its wings from Mojave Airport to Edwards Air Force Base, where the airframe was incorporated into the System Integration Laboratory building at Edwardsburg Flight Test Center to be used to fit and test various components. The SIL was built primarily to test the COIL at a simulated operational altitude, and during that phase of the program, the laser was operated over 50 times, achieving firing durations representative of actual operation engagements. These tests fully qualified the system so that it could be integrated into the actual aircraft. Following the completion of the tests, the laboratory was dismantled and the 747-200 fuselage was removed. The YAL-1 first flew in 2002 but did not test fire its low power laser at an airborne target until 5 years later in 2007. January 2010 saw the first deployment of the YAL-1's high energy laser when it intercepted a test target. Shortly after, it succeeded in destroying a further 2 test missiles. Besides the COIL, the system also included 2 kW class target illuminator lasers for tracking. On March 15, 2007, the YAL-1 successfully fired this laser in flight, hitting its target. The next phase in the test program involved the surrogate high energy laser, SHEL, a stand-in for the COIL, and demonstrated the transition from target illumination to simulated weapons firing. Subsequently, there was a test launch from California coast on June 6, 2009. At that time, it was anticipated that the new airborne laser aircraft could be ready for operation by 2013 after a successful test. On August 13, 2009, the first in-flight test of the YAL-1 culminated with a successful firing of the shell at an instrumented test missile. In December 2011, it was reported that the program was to be ended after 16 years of development and a cost mounting over $5 billion. While in its current form, a relatively low power laser mounted on an unprotected airliner may not be a practical or defensible weapon, the YAL-1 testbed is considered to have proven that air-mounted energy weapons with increased range and power could be another viable way of destroying otherwise very difficult to intercept suborbital ballistic missiles and rockets. On 12th February 2012, the YAL-1 flew its final flight and landed at Davies Monthan Air Force Base in Arizona, where it was placed in storage until it was ultimately scrapped in September 2014 after all usable parts were removed. In theory, the airborne laser could be used against hostile fighter aircraft, cruise missiles, or even low Earth orbit satellites. However, the YAL-1 infrared target acquisition system was designed to detect the hot exhaust of transcontinental ballistic missiles in boost phase. Satellites and other aircraft have a much lower heat signature, making them more difficult to detect. Aside from the difficulty of acquiring and tracking a different kind of target, ground targets such as armored vehicles and possibly even aircraft are not fragile enough to be damaged by a megawatt class laser. However, these plans never materialized. That's all for today. Thanks for watching and be sure to subscribe to this channel.